2017 brought historic snow levels to the Sierra Nevada mountains of Northern California. In addition to ending years-long drought, the heavy rains of January and February have combined with a snowpack with high water content to create the possibility of flood threats through early summer.
We've had quite an extreme year this year. It stands out distinctly from historical years, gets us up into larger accumulations both in snow and in precipitation. A lot of snow accumulation. And these are associated with storm types called atmospheric rivers, and we've had a larger number of them this year than in a typical year.
From a rainfall perspective, especially in the Northern Sierra, we set a record this year for the most accumulation during a water year. The previous year was 82-83, was about 88 inches or so, and this year we surpassed that fairly easily in April, and we're above 93-94 inches at this point.
The 2017 water year ranks with the top 5 for snowpack. That snowpack is frozen water, water in a solid state, and it will melt. The question is, how fast will it melt, and how long will it take?
The snow is so deep, and really the primary driver of snow melt is not necessarily temperature, but solar radiation.
And what you need is a clear sky for that radiation to make it all the way down to the earth. A good chunk of it gets reflected off that white surface of the snow. Certainly as you get dust on it, wherever it gets a little darker, it's better able to absorb that energy. And as it absorbs that energy, it gets enough then to make that transition from solid to liquid. Instead of it being a peak and falling off rapidly, this will kind of be a much more broad and sustained elevated flows.
Instead of seeing our peak melt dates in mid-April to say early May, depending on the watershed, we're now seeing them in early May to possibly early June. So you're delayed 2 to 3 weeks, and that means you're going to have heavy runoff all the way into July. During a normal year, the melt pattern can be handled quite easily by the reservoirs and then the downstream river channels below the reservoirs. In a heavy snowpack like this year, that probably means like you had a lot of rain during the wintertime too, which we did. And now the reservoirs are full with the snow still sitting up there. Is you can't just release anything you want. All of these reservoirs have the same issue. Lots of snow, relatively full reservoirs, and a very limited capacity to release water at too high of a rate downstream. It requires a lot of coordination between the Department of Water Resources and our main partners, which are the reservoir operators, the Army Corps of Engineers, for example, to talk about how we can release that water, almost like a stoplight effect. Almost like, okay, Tuolumne, go ahead and release some water. Merced, can you hold back for a little bit? Oh, okay, now you can release, and San Joaquin, you hold back. And without this coordination and this willingness for all these individual reservoir operators to come together, the situation could be exacerbated much worse than it is.
Massive amounts of water rush downhill into reservoirs, which are meant to hold and conserve that water. With this year's heavy rains and accumulated snowpack, the reservoirs must discharge large amounts of water to conserve room for the incoming snowmelt.
This is a seepage berm that was put in mid-February or so. It reinforces the levee. Underneath here is what was called a boil field, which was there were probably 40 or 50 small boils that water was seeping through.
The Reclamation District levees in the Delta were formally started being constructed around the 1850s. That's right after the Gold Rush era. And since 1980 to current, we've done substantial amount of improvement, bringing the levees taller, wider, and higher to account for the flood threats and to try and avoid the flood threats that come about every 10 years into the system. So back in the 80s, 1982-83, we had quite a few floods. The most recent flood event we had here in 2017, we virtually had no flooding. No islands went under and very little distress associated with the flood event. So we've been very successful in what we've been doing. There's always what we call trigger points. So when the river gets to a certain condition on a rivering system, once it gets to a certain height, the water gets above the ground behind the levee, you'll start to see conditions change. So that's when you start your patrols, and you start off with once a day, twice a day, then you have it once every hour, 24 hours a day.
Well, we're protecting the life and the property of the district, and you know, we're the trustees of the district, which we're elected officials. There's 3 of us, and you know, we maintain the levees, we repair the levees as needed. We have staff that's constantly cleaning, monitoring our pump stations. There's 4 pump stations, pumping the drainage water. All the water from the farm that drains, we have to pump that. The seepage water we're pumping, it's a full-time position. See the water running? It's actually running down.
Reclamation districts represent feet on the ground and eyes open for potential danger on the levees that protect property and people from the saturated soils along rivers and in the delta. River levees and levees in the delta both face immense water pressure. This year, however, that pressure is higher, and especially for river levees, over a greater than usual period of time.
In the delta, the water is up against the levee and well above the ground behind the levee 24 hours a day. So the levees in the delta act more like dams, where there's water against them continuously and the ground behind them is substantially subsided, well below sea level, upwards in the range of 20 feet. So they're holding back a tremendous volume of water all the time, whereas in the riverine systems, it's only during high flows that you see that water change, where it comes up out of the what they call the flow channel up onto the levees, and then the levees then protect the ground behind the levees.
You have an infrastructure in the valley, levees and a flood control system that it's old, and there has been repair and there has been attention to it, but let's face it, it's old and it's not always going to face this kind of challenge, and so that part of it too can be unpredictable. How are the levees going to behave when you put a stress of well above average flows on it from January all the way to July? That's not a normal situation.
California, since October, has experienced 30 what we call atmospheric rivers. Used to be called Pineapple Expresses, and the last ones came through somewhere around the end of February. Thankfully, our March and April rains have been pretty small. The snowpack is just now starting its melt, and that is going to cause us to be in the emergency mode maybe into late July or into August. There's dangers out there. These rivers are causing trees to be pulled away from the ground, and they're floating. We've had appliances, chemical drums. We've even found some big sheets of plywood floating around. We do, though, ask you to be aware of your own situation. When you're out on the waterways, be careful. Know where to get information and protect yourself. Be safe out there. Enjoy the conditions. Enjoy the water, the delta, but just be aware. This emergency is not over. Thank you.